Okay, now let's see this question. This question came in GATE 2014 for 2 marks. The question is, consider the following relation on subsets of set S of integers 1 to between 1 to 2014. So there is a set S, and these are the integers from 1 to 3 to 2014. Okay, and they are saying that the relation is on the set of subsets of set S. So what are the subsets of set S? First it can be phi, which is null set or empty set. Another one can be something like, so 1 2 1 1 3, you can understand, like 2 2 4. Okay, that can be one thing. 5 25, so you can understand there can be a lot of them. So let's say 2 3 8 2014, something like this. There can be one of them will be obviously a universal set. So universal set U, which is basically everything, which is basically S only. So 1 2 3 all the way till 2014, everything. And you know that there will be a lot of them. To be precise, 2014 elements are there, so 2 raised to the power 2014 such subsets will be there. However, we are interested in a particular situation where they are saying that for two distinct subsets U and V, we say that U is less than V when the minimum element in the symmetric difference of two sets is U. Okay, so I'll just show it by an example what they are saying. Firstly, let's understand what is symmetric difference. So symmetric difference of two sets A and B is essentially A minus B union B minus A. So when we say that, it means that if there is a set A and if there is a another set B, then A minus B, it means all these elements which are only in A but nothing they have in common with B, and union B minus A. So all the elements which are in B but they have nothing in common with A. So all these elements. Okay, and these elements, this set is basically symmetric difference. We also denote it something like A symmetric difference B. Okay, so this is the thing. Now let's talk about how this minimum element is found, and then so how can we say that U is less than V as per the definition they have given. So let's take two particular elements. Let's say elements of this subset. So let's say take this subset and this subset. So let's say this is A and this is B, and we have to find which one is smaller, which one is bigger. So A and B, these are these two subsets, and we have to find relation between them. Okay, so what they are saying that firstly we find the symmetric difference. So if A is this and B is this, what is the symmetric difference? A symmetric difference B, what is that set? That set is basically what? A union B, and then we have to remove all the things which are overlapping. So which are in both the sets, we have to remove that. So in that, so you can understand that this thing can be written as like this also: A union B. Okay, A union B minus A intersection B. So this thing can be written like this also. So when we are trying to find asymmetric difference B, then we take the union of both and then remove what are common. So what is common? See, here 2 is there and here 2 is there. So only element which is common is 2. So 2 will be removed, and rest of them will be existing. So 4 will be there, 3 will be there, 8 will be there, 2014 will be there. So you can understand that this is the symmetric difference. Now after that, they are saying that the minimum element in the symmetric difference. What is the minimum element in this symmetric difference? That is 3. So if the minimum element in the symmetric difference of two sets is in U, then U is smaller than V. So in this case, this element, which is the minimum element in the symmetric difference, that element is in B. So we can say that B is smaller than A. So now we have understood that how two sets are compared. So how we can say that A is greater than B or B is greater than A. In that sense, how we can say that we have found. Now they have given the two statements and we have to find which of them is true. the first statement is there is a subset of S that is larger than every other subset. So is there any subset which is larger than every other subset? Okay, so I will give you an example. Let's take any set. Let's take any set. Let's take this only. So let's say that this set is called X, and we have to. This can be any set. Let's we have just chosen any random set, but if we try to compare it with this set, which is the empty set, okay, then with respect to empty set, what is the relation of X with respect to empty set? Okay, so firstly again we will try to find the empty set and this X set. We will try to find what is the symmetric difference. So you understand that there is nothing common. There is nothing common here. So the union minus intersection is nothing. So that will X union phi will be X only, and then minus intersection is nothing. So nothing can be removed, and that's why it will be X only. So you can understand that when we take this symmetric difference, this will be basically X only. You must have directly read this formula also, that symmetric difference of any set with respect to phi is that set itself. Okay, now we have seen that the symmetric difference is this. What is the minimum element in this symmetric difference? There will be some minimum element. So in this case 2 is the minimum element, and that will lie in which set? Obviously in X, because that is the minimum element in this set. Symmetric difference is same as set X itself. So in this case we will see that X is smaller than phi, okay, as per the definition of what they are saying, that smaller is what. Okay, so as per the definition, this thing will always be satisfied for any set, any set. Okay, so any set means removing except phi. So except phi, whatever are the non-empty sets, for every set this thing is satisfied. Now once we understand that, then we can say that this statement is true. There is a subset of S which is phi, which is larger than every other subset, which is true. So this statement is definitely true. If that subset is phi. Now let's talk about the second statement. There is a subset S that is smaller than every other subset. Okay, so let's compare any set, any random set X with respect to the universal set. Then we will find out what is the thing. Okay, so in universal set, what we are going to have is that when we are trying to find universal set and X, if we are trying to find the symmetric difference, then what will happen? Whatever are the common elements, that will be removed. So 2 is there, and 2 will definitely, this is the universal set. So all the elements which are in X, definitely that will be here also. So 2 will be there, 3 will be there, 8 will be there, 2014. So you can understand that all the elements which are not in so basically not in it will basically U minus X. Okay, so this set is basically the symmetric difference. So from U you remove all the elements in X, and that will be a symmetric difference, because everything will be here. Now that is basically, in this case you can understand, it will be 1, then after that 2, 3 both are there, then it will be 4, 5, 6, 7, and then see 8 will be common, so that will be removed, and then 9, 10, and then all the way till 2013, because 2014 will be also common. So you can understand what I am trying to say, that this will be the symmetric difference. Now what is the minimum element? Minimum element in this case is 1, and that will obviously lie in universal set. Why? Because whatever elements were there in X, that has already been removed, everything that whatever elements are in there in X, that will never come in this symmetric difference, and that's why whichever element which is smaller among all of them will definitely lie in U. In that case, I can say that universal set U will always be smaller than X as per the definition of smaller what they have given. So in that case, I can say that there is always a subset which is universal set which is smaller than every other subset as per the definition. So universal set is some set which is smaller than every other subset. So S2 is also true. So which one of the following statements is correct? Both S1 and S2 are true. So the answer is A.